Okay, so this video is going to focus on looking at, I think mainly ellipses, but looking at the path, some information about the path, and then creating parametric equations that describe that. And oh, that's fun. And so, what happened? There it is. Thank you. And so the thing is that, oh, thank Thank you. Okay, not really sure what that's all about. And so the hard part is not going to be getting the actual equation in terms of like how I could see in the x direction is going 10 and in the y direction is going 6. So that part's easy to construct. What's going to make it hard is making sure we get the right place of where it starts, and then also making sure we go in the right direction at the right rate or the right path. So let's look at this first example here. It says at time equals 0, the particle is at the point 10, 0. So that's just right here. And at time equals 4, the particle is at 0, 6, which is up at the top. And the particle moves in a counterclockwise direction. And we sort of have to assume that it's moving at a constant speed. Okay, so going from here to here is taking 4 seconds, and then 4 more seconds, so that's 8, so then that's 12, so we know that it is 16 seconds. So my period is 16 seconds. So one thing I might want to think about is that that thought of like, oh, well, if I have 2 pi over b, whatever that coefficient is, I need to make sure that that gives me a period of 16. And so then, again, kind of like similar to finding an equation, when we did this back in the early parts of the semester, we know that my b, or my coefficient, is going to be pi over 8. That's like the frequency of it. Okay. Now, the fact that I'm starting here at time equals 0 means that I want my cosine function to be associated in this direction, which is the x. And that's sort of natural. But think about cosine gives you something at 0. So the cosine function always has to go to the start. And since I'm starting on the positive x, I need to make sure my cosine is starting as positive. So I know that, and it's stretched by a factor of 10. So I know that like x is going to have to equal 10 cosine, and we already know that it's pi over 8 is the frequency, t, and then the y value would be 6 sine of pi over 8 t. And we have one more data point we could check. We could try putting in time equals 4. And at time equals 4, that's giving you pi halves. And cosine of pi halves is 0, so that's good, because we wanted the x value to be 0. And the sine of pi halves is 1. 1 times 6 is 6, and we wanted that y value to be 6. So that's your first example. And things that I've pulled out from this, and things that I think are important, worth saying again, cosine goes to the start. So if you're starting on the x-axis, then you want cosine to go to the x-axis. If for some reason, we'll see an example where you start on the y-axis, then you're going to want cosine to go to the y function, because cosine actually gives you a value when you substitute 0. Cosine of 0 is 1, and then you can multiply by the coefficient. Okay. So the 10 and the 6 are going to be up here for this ellipse for all of the examples, because no matter how fast or where you start, you're only going to be stretched 10 in the x and 6 in the y. So like those are going to be the same. What's going to change is our parameter, how fast are we going, and maybe the location of that cosine and sine function, depending on where we're starting. Okay, so now we're going to start at 10, 0, same spot, but this time we're going to go at time equals 5, 0, negative 6, and the particle moves in a clockwise direction. So kind of coming back up here to our image, we're starting here at time equals 0, and we're going to be at 0, negative 6 in this clockwise direction. and it's going to take us 5 seconds. So again, assuming we are going in a consistent manner, a uniform speed. So 5 seconds, 10 seconds, 15 seconds, or 20 seconds to get us one time around. So I at least now know that if it takes 20 seconds, so 2 pi over b is equal to 20 seconds for the whole period to go around. That means b has to be equal to pi over 10. And I do know that I'm starting at 10, 0. And 10, 0 is starting on the positive x-axis. It's starting here. So I know cosine should go with x. So x is equal to 10 cosine. And then it's going to be our period, or I should say our frequency of pi over 10 to get us the right period. T, there it is. Okay, and then the sine function will have y. And we go pi over 10 t. But now notice, oops, there we go, that I need to go down to get to that point there, -6. And so what I can think about is then making this a -6 value, because that'll make sure that my y values start negative. And the thing is that when I have this, like when I know I'm starting x equals 10, like I know I'm starting there. Like I know I'm starting right here at this point. Like from this point, I either can go up or I can go down depending on what direction it tells me, right? Clockwise or counterclockwise. Well, going up or going down is associated with changing a y value. So if I'm going up, notice when I go up initially, all those y values are positive. If I go down, all those y values are negative. So when they tell you the direction, go in a counterclockwise direction, that translates to make sure your y's begin negative. And that's exactly why I need to make sure that's a -6 there. Okay, so let's look at the next example. And again, at some point, maybe pause the video. You try it and then see what I say. Okay, so now we're starting at -10, 0. So we're starting at the other side of the x-axis, but we're still starting on the x-axis. So the fact that I'm still starting on the x-axis, -10, 0, here's where I'm starting, that still tells me that I want to make sure cosine goes with x. But like the last example, and maybe you've already kind of seeing this, because it's starting at -10, I'm going to let that first coefficient be negative. So I know x is going to be -10 cosine. So it has to be a -10 cosine, because that's where like cosine of 0 actually gives you something. Okay. Now, at time equals 1, the particles at the point 0, -6. So now I'm down here. Time equals 1. And in what direction are moving? Counterclockwise. Good. So like 1 second to get there. Again, assuming uniform speed, 2 seconds. 3 seconds, and then 4 seconds. So it's taking us 4 seconds to travel this path. Remember, it's 2 pi over b is equal to 4. So that means b has to be pi over 2. So that would go here, cosine of pi over 2t, introducing that parameter. Okay, excellent. Now, I need to go down here. And because I'm encountering y's being negative initially, that means my y component also has to be negative. So y equals -6 sine of pi over 2t. And again, this negative really doesn't necessarily dictate what, like, oh, it's always going to be counterclockwise. There's always going to be clockwise. Because notice it's going to depend on where you started. In the last example, we started on the right with x being positive, but we needed the y to be negative to go in a clockwise direction because we wanted to encounter negative y's first. Here, we're starting with x being negative, and because I want to go in a counterclockwise direction, that also involved making y negative initially. So I needed that to be negative as well. Okay. Hopefully this is making sense. And again, go back, replay the video, look through the example, listen to what I'm saying, just because that the hardest thing is making sure you have the right parameters. So what's the frequency here? And then also making sure you have the right positives, negatives. Okay, let's look at the next one. This one I can already see and sneak a peek. I'm starting on the y-axis, 0, 6. So that's the first time where cosine's not going to go with x. Because if I think about, again, cosine of 0 actually gives you something. So I need to put the cosine function with the y variable. So time equals 0. I need to make sure that my y value gives me something, and it's up to 6. So I'm going to start with y is equal to 6. Oops, 6. There it is. Cosine. And notice that the 6 is still with the y because 6 is modifying how far you're going in the y direction. 10 is going to modify how far you're going in the x direction. So those can't change. But what can change is the cosine sine function, because depending on when you get there is what, is what function you would have chosen. Okay, at time equals 3, the particle is at the point -10, 0. So we're right here. At time equals 3. And it does say we are moving in a counterclockwise direction. So we're going in this direction. So it took me 3 seconds to get there. It'll take me 3 more seconds. So that's 6, and that's 9, and then that's 12. So 2 pi over b is going to give us a period of 12, which means b should be pi over 6. So I know, oops, there it is. So I know this is pi over 6. So cosine of pi over 6 t. And I know my sine, my y is positive because I'm starting on the positive y-axis. If I would have started on the negative y-axis down here, down in that spot, then I would have had to make y negative. Okay, now let's figure out, should this 10 for cosine, for x be positive or negative? So I do know it's 10, and I know it's going to be the sine function, and it's still going to be pi over 6. So let's think about, I'm here at the top of the I'm at the top of the unit circle, or top of the ellipse, and I need to go in a counterclockwise direction. So right now, my like if I'm at the top here, my x component is 0. It's neutral. And the first x's that I need to encounter are on the left of that point. And so that'll guarantee me to be going in this counterclockwise direction. So if the x's need to be going to that are negative, that I need to encounter first, that means I need to make sure that my x's begins negative. So that's why I need to know it starts as a -10 to get me to go to the left, because that's where the first negative x's are. Okay, I think there's one more, right? Example E, yeah, okay. So at time equals 0, the particle's at 0, -6. So now we're starting 0, -6. We're starting down below. So notice it's the y-axis, and it's negative. So automatically, that tells me that that tells me that my y value has to have the cosine function, and it needs to start out negative, because I'm starting below the x-axis. Okay, and that means this is going to be 10. Could be positive, could be negative, not sure just yet. Sine. Okay, let's do the period. It says time equals 7, the point's at 10, 0. So now I'm here, took me 7 seconds. The particle's moving in a clockwise direction. So before you instinctively do this, because that seems to have made sense, it's actually going in a clockwise direction. So we're actually going this way. So this is going to be an awkward fraction. It's taking me 7 seconds to go 3/4 of the way. And so if I think about, okay, so it took me, like, that's 3 regions in that 7 seconds. So it's like 7/3 of a second here, and then 7/3 here, and then 7/3 here. So if I have 3 groups of 7/3 of a second, that would have given me 7 seconds. So that's how I'm kind of calculating. It takes me 7 seconds to get here. So 1/3 of it, 2/3 of it, 3/3 of it. So that means it takes me 7/3 for each region. So to get to the 4th region, I would need 4 of those 7/3. In other words, 4 times 7/3 means it's going to take me 28/3 of a second to go around once. And so then I could be, okay, so 2 pi over b is equal to, we say 28 thirds. Oops, that's a terrible 2, 28 thirds. So then I can cross multiply. Maybe this one's not as obvious. So 6b is equal, sorry, 6 pi, I should say, is equal to 28b. So divide the 6 across. So pi is equal to 28 over 6. I'm sorry, divide the 28 across. So b is equal to 6 pi over 28, which is 3 pi over 4. Sorry, that is, wow, 3 pi over 14 equals b. Okay, so that becomes my coefficient. So now I know it's negative 6 cosine of 3 pi over 14t. Okay, and this is still going to be the same frequency of 3 pi over 14t. But let's see, what kind of x's do we encounter first? So we start at like neutral x, right? Because we're down here, the x down here on the lower y-axis. Oops, the color didn't go. One more time. It's a little bit slow. Here we go. Let's pick that color. So we're down here, and we're going in a clockwise direction. So the kind of x's that we're encountering first are to the left of this point, which means our x's that we need to encounter first have to be negative. So we need to make that a negative as well. So negative 10 sine would be our x value, and negative 6 cosine would be our y. Okay, and again, what I really like about this is that it actually makes us think about our sine and cosine functions, and those, I mean, are the basic building blocks of trig. So it's a great way to sort of end, well, at least one of our last topics in trig, and that's just by looking at these functions through the lens of parametrics. Okay, so practice those problems, check out the Canvas quiz, at least like the checkpoints, and then email me if you have any questions.